Hello everyone, I am Sunita Swai, Faculty Data Science at Techno India University, Kolkata. Today, I am going to brief the topic TCP/IP model, which is coming under the subject computer networks, which is also the kind of concepts required for the cloud computing environment. So, before going to the cloud computing environment, we must understand several computer networking concepts because computer networks is the kind of technology where the data communication occurs, and cloud computing environment is based on data communication because over the internet we are accessing several resources, whether it is a platform as a service, software as a service, or infrastructure as a service. It is only possible via the computer networking environment. So, prior to the cloud computing concepts or different types of architectures and the functionalities of cloud computing, we must understand the basic concepts of cloud computing and the configuration which is needed for functioning one cloud computing environment. So, today I am going to explain what is this TCP/IP model. So, TCP/IP, these are two protocols. Protocols means sets of rules and regulations to govern something. So, TCP stands for Transmission Control Protocol. IP stands for Internet Protocol. TCP/IP model was developed prior to the OSI model. OSI model stands for Open System Interconnection. So, OSI model is the theoretical model and TCP/IP model is the practical model. The TCP/IP model is not exactly similar to the OSI model. The TCP/IP model consists of 5 layers: the application layer, transport layer, network layer, data link layer, and physical layer. It's having 5 layers. The first 4 layers provide physical standards, network interface, internetworking, and transport functions that correspond to the first 4 layers of the OSI reference model. Thus, OSI reference model is having 7 layers. So, in OSI model, these 4 layers are represented in TCP/IP model by a single layer which is called as application layer. So, TCP/IP is a hierarchical protocol made up of interactive modules, and each of them provides specific functionality. So, here hierarchical means that each upper layer protocol is supported by 2 or more lower level protocols. Let us discuss what is the functions of TCP/IP layers. So, as I briefed, it is having 5 layers, namely physical layer, which is the first layer. Data link layer is the second layer, means from bottom to top approach. Layer number 1 is physical, layer number 2 is data link, Layer number 3 is network. Layer number 4 is transport. And the last layer is called as application layer, which is consisting of application, presentation, and session of OSI reference model. So the last 3 layers of OSI has been combined over here to make it application. That is combination of session, presentation, and application of OSI reference model. So the first layer, which is called as the physical layer. Here, the physical layer of OSI reference model is called as network access layer of TCP/IP protocol suite. So, network access layer is the lowest layer of TCP/IP model. So, network layer is the combination of the physical layer and data link layer defined in the OSI reference model. It defines how the data should be sent physically through the network. So, generally, this lowest layer of TCP/IP is responsible for the transmission of the data between two devices on the same network. So, this layer is responsible for sending the physical data through the network. So, this physical environment means it tells about the physical configuration, your mechanical, electrical specification are installed or are called as network access layer. So, physical communication medium, which is necessary for data communication, is mentioned in the network access layer. So we are discussing the functionalities and how it works in different types of layers present in TCP/IP protocol suite. The second layer of TCP/IP model is internet layer. So the internet layer is also known as the network layer of OSI reference model. So in TCP/IP model, this is called as internet layer. So the main responsibility of the internet layer is to send the packets from any network. So internet layer has the functionalities to send the packets or the data packets from any of the network, because we are using this particular model for data communication. So they arrive at the destination irrespective of the route they take. This is the purpose of the internet layer. So this internet layer is to send the packets from any network and they arrive at the destination irrespective of the route they take. So any route they may follow to reach at the destination station. Following are the protocols used in this layer are IP protocol. So this IP means internet protocol that is used in this layer, and it is the most significant part of the entire TCP/IP suite. So what are the responsibilities of this IP protocol? Let us discuss. So the responsibilities of IP protocol is IP addressing. So one by one, we'll discuss what are the different responsibilities of this protocol. So first and foremost, responsibility is IP addressing. So this protocol implements logical host addresses, which is known as IP addresses. So the IP addresses are used by the internet and higher layers to identify the device and to provide inter-network routing. So this IP address, that is identify, which is the purpose of this IP addressing, that the particular address of the destination and how this acknowledgement will be received from destination to source. So the higher layers to identify the device, and it also provides the inter-network routing. Next responsibility, excuse me, responsibility is host to host communication. Means it determines the path through which the data is to be transmitted. So how the data is to be transmitted? Host, a particular host to host. This IP addressing or IP protocol determines the path. So in through which path the data has to be communicated. Next is data encapsulation and formatting. So an IP protocol accepts the data from the transport layer protocol. So an IP protocol ensures that the data is sent and received securely. It encapsulates the data into messages known as IP datagram. So obviously, data needs to be formatted and it should be encapsulated. And IP protocol ensures the data is sent and the security also maintained. Next responsibility of this IP protocol is fragmentation and reassembly. So the limit imposed on the size of this IP datagram by data link layer protocol is known as maximum transmission unit, MTU. If the size of IP datagram is greater than the maximum transmission unit, then the IP protocol splits the datagram into smaller units. So that they can travel over the local network. So this fragmentation can be done by the sender or intermediate router. So at the receiver side, all the fragments are reassembled to form an original message. Next functionalities of this IP protocol is routing. So when this IP datagram is sent over the same local network, such as LAN, MAN, or WAN, local area network, metropolitan area network, or wide area network, it is known as direct delivery. So when source and destination are on the distance network, distant places, then the IP datagram is sent indirectly. So this can be accomplished by routing the IP datagram through various devices, which is called as routers. So the purpose of the router is to send the data or the datagram when source and destinations are on distant network, not in the same network. So by this routing technique, these IP datagrams are sent to some other networks destination device. So in this ARP protocol, this IP protocol or second layer, that is different types of protocols are present. So different protocols responsibilities are different. Like in this network layer, in IP protocol, we are having ARP, which is called as address resolution protocol, RARP, that is reverse address resolution protocol, ICMP, internet control message protocol, IGMP, internet group message protocol. So these are the various protocols present in this network layer. So how the datagrams will be transferred from one network to another network or within one network, different types of protocols are having different functionalities. Let us discuss what is ARP. So ARP protocol, ARP stands for Address Resolution Protocol. So ARP is a network layer protocol which is used to find the physical address from the IP address. So the two terms are mainly associated with ARP protocol. That is ARP request and ARP reply. So in ARP request, when a sender wants to know the physical address of the device, it broadcasts the ARP request to the network. That is the responsibility of ARP request or ARP protocol that request uh, functionalities. ARP reply, every device attached to the network will accept ARP request and process the request also. But only recipient recognize the IP address and sends back its physical address in the form of ARP reply. So the recipient adds the physical address both to its cache memory and to the datagram header. So the ARP protocol is used for physical addressing from the IP address. So these two terms like ARP request and ARP reply is required for functioning this ARP protocol. Next, we'll discuss this ICMP protocol. So ICMP protocol, it stands for Internet Control Message Protocol. So this but different protocols are having different responsibilities. So the ICMP protocol has the mechanism used by the hosts or routers to send notifications regarding datagram problems back to the sender. So Internet Control Message Protocol is having this particular feature to send notification regarding the datagram problems back to the sender. So this particular notification comes by this to the sender device. So a datagram travels from router to router until it reaches its destination. If a router is unable to route the data because of some unusual conditions, such as disabled links, a device is on fire, or network congestion, then ICMP protocol is used to inform the sender that the datagram is undeliverable. This is the major responsibilities of ICMP protocol. So, ICMP reply. So, it is used to check whether the destination device is responding or not. So, the destination device is responding, then only this protocol transfers the data, means it gets the information regarding the connectivity between source and destinations. The core responsibility of ICMP protocol is to report the problems, not correct them. The responsibility of the correction lies with the sender only. So the responsibility of ICMP protocol is to report the problem, not for correcting. So ICMP can send the messages only to the source, but not to the intermediate routers, because the IP datagram carries the addresses of the source and destination, but not the router through which it passes. Obviously, the datagram where it starts from that particular source has to be informed regarding the kind of problems arised with that particular packet. Next, come to the transport layer. So the transport layer is responsible for the reliability, flow control, and correction of data which is being sent over the network. So the two protocols used in the transport layer are UDP and TCP. UDP stands for User Datagram Protocol. TCP stands for Transmission Control Protocol. So User Datagram Protocol provides connectionless service and end-to-end delivery of transmission. It is an unreliable protocol as it discovers the errors but not specify the errors. User Datagram Protocol discovers the error and ICMP protocol reports the error to the sender that the user datagram has been damaged. And UDP consisting of several fields like source port address, destination port address, total length, checksum. So these are having different fields present in the UDP. So in the UDP, these are the different segments, different functionalities are divided into this particular format. Transmission control protocol, which provides the full transport layer services to the applications. It creates a virtual circuit between the sender and receiver. And it is active for the duration of the transmission. TCP is reliable protocol as it detects the error and retransmits the damaged frames also. That's why it is called as reliable protocol. Therefore, it ensures all the segments must be received and acknowledged before the transmission is considered to be completed. And a virtual circuit is discarded. At the sending end, TCP divides the whole message into smaller units known as segment. And each segment contains a sequence number which is required for reordering the frames to form an original message. At the receiving end, TCP collects all the segments and reorders them based on sequence numbers. Now, come to the last layer or topmost layer of TCP/IP protocol suite, which is called as application layer. So, an application layer is the topmost layer in the TCP/IP model. It is responsible for handling high-level protocols, issues of representation also. This layer allows the user to interact with the application. So when one application layer protocol wants to communicate with another application layer, then it forwards its data to the transport layer because it is peer-to-peer communication. Each and every layer of TCP/IP are having several functionalities, and one after another, according to their responsibilities, if any kind of request comes, they does their job accordingly. There is an ambiguity occurs in the application layer. Every application cannot be placed inside the application layer except those who interact with the communication system. For example, text editor. So, this text editor cannot be considered in application layer, while web browser using HTTP protocol to interact with the network where HTTP protocol is an application layer protocol. Following are the main protocols used in application layer like HTTP, SNMP, SMTP, DNS, Telnet, FTP. These are several application layer protocols. HTTP stands for Hypertext Transfer Protocol. It allows us to access the data over World Wide Web. SNMP stands for Simple Network Management Protocol. It is a framework used for managing the devices on the internet by using the TCP/IP protocol suite. SMTP stands for Simple Mail Transfer Protocol. The TCP/IP protocol that supports the email is known as Simple Mail Transfer Protocol. DNS stands for Domain Name System. An IP address is used to identify the connection of a host to the internet uniquely. Telnet, it is an abbreviation of terminal network. It establishes the connection between the local computer and remote computer in such a way that the local terminal appears to be a terminal at the remote system. FTP stands for File Transfer Protocol. It is a standard internet protocol used for transmitting the files from one computer to the another computer. So today, we have discussed the several layers, its functionalities of TCP/IP protocol suite, and different protocols present in several layers along with their protocols. Thank you.